This is Dr. Wood with Citadel Civil Engineering. This is CIVL 203 Dynamics. And in this lecture, we're going to talk about Learning Objective 4.1, which discusses rigid body translation. Now, it turns out this particular case is actually pretty easy, but I do want to walk us through this because we're transitioning now from talking about particles and looking at particle kinematics and particle kinetics into rigid body kinematics and rigid body kinetics. We're going to start with rigid body kinematics, which is in chapter 15 of your textbook. And as we do that, I want to put some definitions and remind us of some things. So the first thing I want us to remind us of is what a rigid body is. Hopefully we remember this from our study of statics, but when we think about a rigid body, this is going to be something that has mass and shape. All right, so mass and shape. I'm going to kind of blow this up a little bit so we can see it better. Okay, so mass and shape when we think about a rigid body. And the key to it being rigid is it means that we're going to have fixed distances between points on the body. So we might say that something like a meter stick was a rigid body. I have a meter stick here. And by rigid, we mean that this end of the meter stick is always 1 meter away from this end of the stick. And it's never going to change as long as we have it acting in a rigid manner. And so that becomes very important for us to be able to do this. Now, when we talk about rigid body kinetics, or kinematics, sorry, it means that we're going to be thinking about the position, the velocity, and the acceleration of all points on the body. So when we were doing particle kinematics, we were thinking of it as having only mass without shape, which meant that we could model it as a particle. And so fundamentally what we were doing is we were tracking the kinematics of the center of gravity when we modeled it as a particle. Now that we're talking about rigid body kinematics, we want to be able to keep track of all points on the rigid body, kind of regardless of where they are. So that's an important thing for us to think about. Now, when we think about all the different ways things can move, things can translate, and they can translate using rectilinear translation or curvilinear translation. And there's some great figures in your book on how that works. We can then talk about fixed axis rotation, which will be our next video, where things spin around a fixed axis. And then finally, we can talk about general plane motion. So this would be any 2D motion, both a combination of translation and rotation. That'll be the extent of what we discuss in this class, but your book actually goes on to talk about 3D motion as well, both fixed point rotation, so objects rotating about a central point, or general motion, so just free-for-all motion as we go ahead. And so those are all valid ways for us to look at these things. And so when we think about translation, when we say something is translating, what we're saying is that the points move parallel to one another. Now, what's great about this is that means that the velocity or the acceleration or the motion for any given point on the body is equal to the velocity of the center of gravity. Now, when we think about this, this means that this is the same as particle kinematics. So you already know how to do the translation of rigid bodies. If you just model it as a particle, you keep track of where the center of gravity is, the position, the velocity, and the acceleration of the center of gravity. You can now know the position, velocity, and acceleration of any other point. So if we look at my meter stick again, if I know where the center is and I know what kind of motion it's experiencing, you'll notice that every other point on the body is experiencing that same motion. So we have translation. This is rectilinear translation. We can also have curvilinear translation, but you notice that the more or less the meter stick is not changing its orientation. And so whatever path this is traveling on, this end, they're traveling on parallel paths. And so you can just analyze the center of gravity and you'll be in business. Now, we can look at some examples. So if we think about those different types of motion, if we look at these wheels, we're going to have some rotation happening here. Now, it turns out those wheels are going to be translating side to side. So this is not fixed axis rotation. That axis is moving as the train moves. But we'll also have translation of these tie bars. So those bars are going to stay horizontal no matter what. So they're actually experiencing just translation. They're not actually experiencing rotation. So we could look at that. Here's another example. What would we call this? Well, in this case, we do have an axis that's not moving. This reminds me of home, West Texas. My axis that's not moving here, those blades are spinning around that fixed axis. And so we're going to have to use fixed axis rotation to do that and analyze that. And that's where we're going to talk about the carousel. So I look forward to seeing you on the next fixed axis rotation video. This is translation. It's a whole topic of rigid body motion you already know about. Well done.